Titans of text and lords and ladies of labels, it's Prof. G, and in this lesson of CircuitPython School, we're going to learn more techniques to use when writing text to displays. We'll cover padding, background color, line spacing, and text wrapping. Time to drop knowledge and rizz up your display skills. Now, we're building on our prior lessons, so if you're new here, welcome, but you might want to check out the playlist to see how we got here. So plug in your board with your wired up display, and I'm going to work in PyCharm, and I'll start from scratch, but while the techniques we use can work with other boards and displays, I'm using a Raspberry Pi Pico 2W with an ILI 9341 TFT display, so I'm going to be sure to set the code up for that board with my wiring. Now, if you followed our prior lessons, you know that we've already got the configuration code in our CircuitPython tip sheet, so I'll head over there now. Highlight the code for this display, copy it, head back to PyCharm, and paste it in. And I'll change the print statement down here to label padding demo. And the first comment in our code to the name we'll save this file as, which will be label-padding-demo.py. Then below our configuration code, for me the last line is backlight, and above our print statement above the while true, we always create a root group for the display. So that's sort of like the canvas that we add everything to. So we'll create that calling it group, setting it equal to displayio.G group with two parens. Then on the next line we'll say display.root_group, setting that equal to group. And we've now got the equivalent of a canvas on our display that we can write to. And now I don't want to use the built-in terminal IO font, so why don't we load in a font to use? Why don't we call this label_font and set it equal to, and here we access the load font function with bitmap_font.load_font, and in between parentheses, inside double quotes, we just give the string, which is the path to the name of the font we want to load. For us, that'll be /fonts/HELV capital B 18.pdf. Now, I'm going to assume that you followed the earlier lesson and that on your CircuitPy board you already have a fonts folder with this font named inside of it. If you don't, you can head to this GitHub repo, which we used in the prior lesson. I've also got this linked in the description, and you can click on the code button, download the zip, and copy the fonts file to your CircuitPy volume. You should have what you need then. Now let's create a label using what we learned in our prior lesson, so we'll call this first label no_padding. And to create this, we'll say equal, capital L label, and in between parentheses, I'll press return to enter each of the parameters on a separate line. Our font is going to be label_font, comma, make sure you put commas after every parameter. The text is going to be equal to the string no padding, comma. We'll set background_tight equal to capital T true, comma. The anchor underscore point will be equal to, in between parentheses, 0.5, comma 0, comma. And this sets the label bounding box to the top middle. Then we'll set the anchored underscore position equal to, in parentheses, display.width /2, comma, display-height /3, comma, and that'll place the label halfway over and 1/3 down the display. Then something new, we're going to set the background underscore color equal to, in parens, 255,0,0, comma, that's going to be red. And we'll set our color equal to yellow, so in between parens, that's going to be 255,150, 0. Now, every time you create an object like a label, you want to make sure that you do a group.append, passing in the name of the object, so we'll append no_padding. Then I'm going to copy everything I entered for this label and attaching it to the group, paste it below. But let's change this label so that it's called all_sides_padding, and I'm going to paste that in the append statement down below. The text will be all sides padding. We'll set the background_tight to false. And this is absolutely critical. We must have this parameter as false if we want to see the padding show up. Now we'll keep the anchor point where it is, but in the anchored position, I'm going to move the height down. Instead of double slashing at 3 to start 1/3 down, I'm going to double slash, and in parentheses, I'm going to say 3/2. That's going to place this label halfway over, but 2/3 down. You could also multiply by 2/3. Remember that double slash is going to drop any fractional values, which is what we want to do because there aren't any fractional points on our display. But then, let's add our padding below our background colors. And notice as we start to type in padding, we've got 4 paddings for top, bottom, left, and right. We'll set each of them equal to 20. Make sure you got a comma after each parameter. This should give us a padding of 20 pixels on all sides of this label. That padding should be colored in red. So let's save our work with Command-S, Control-S Windows. I'm going to open up our terminal, and I'm going to circup install-A just to make sure that I install all the libraries on my CircuitPy volume. Then I'll get into TO. No errors, and look at that! Just below the feline photobomb, we've got 2 labels, the top one with no padding, the bottom one with padding, 20 points on all sides. Cool. Now remember, if you want to see a color behind background padding, you've got to set your background type parameter to false. If you set it to true, well, let me show you what happens. Save this. We don't see any background padding. And in fact, if we compare it side by side with the previous run, we can see with padding, the label's been shifted down a little bit. With background type set to true, though, we get no padding. Just a little pro tip for you to remember in case you have things set up this way and you're not seeing what you expect. So I'm going to undo to set background type equal to false so that we can see our padding. But you might wonder, well, what happens if we set background type to false and we don't have any padding? So let's do that now up here and save this. And I haven't gotten any confirmation yet from the folks from CircuitPython, but I think this might be a bug. Even though we have no padding with background type set to false, we see that we've got this odd padded area on top of the label. That looks like a bug to me because it's even too much for things like accent marks or the other marks that you might have on top of letters in Nordic countries. You only see this in the bitmap underscore label class, not in the labels label class. Bitmap underscore label is supposed to be drop-in compatible with label. My guess is this might be a bug, but no, at least for now, if you set background underscore type to false, you're going to get this additional padding up top. Either way, you're armed with knowledge. So let's save this to our CircuitPython school folder and close that outermost folder and try another example. Now let's talk line spacing. So we'll change our first comment to line-spacing-demo. I'll change the print statement just before while true to say line spacing demo, and I'll delete my second label for now. I'll change the name of our first label to single underscore spaced and copy that name and paste it into the append for group. And I'll change the label bounding box anchor point to 0, 0. And I'm going to change the anchored position for this to anchor it in the upper left-hand corner, 0, 0. I'll get rid of both of these comments and get rid of my background color. I also think I want my first label to have the color 255, 255, 255, which is white. And why don't we change our text string to read, this is a space, and then we'll put in \n. Remember, that's an escape character that will force a line feed. It'll force a new line in our string. And then after that, right after the n, we'll say single spaced label. So this is a single string with two lines in it, one that says this is a, and the other that says single spaced label. So we've got two lines, so we can check our spacing. So let's add a line spacing parameter. We'll do that just below the anchored position. We'll say line underscore spacing, set this equal to 1, comma, then let's highlight the single spaced label, copy it, paste it down below, and compare this to a double spaced label. We'll name this double spaced. Make sure you copy that name and paste it in the append for group. We'll change the anchored position for this to 0, display.height /2. That'll start this halfway down through the display. We'll set line spacing to 2. Why don't we set the color to yellow, 255, 150, 0. And we'll replace the string with, and this is a space \n double dash spaced label, save. No errors, and hey, look at that. The top is single spaced, the bottom is double spaced, looking good. A lot of times I like to make things less than single spaced. Let's change this first single spaced label, and just for consistency, I'm going to change the name from single spaced to tight underscore spaced. Make sure that's inside your group.append. And why don't we change our text to read, this is a, then after the return, 0.7 line space label. Then we'll change our line spacing to 0.7. Save this, Command S or Control S Windows, and the code will execute, and look at this, even tighter. From a design perspective, I think you'll want to use less than one line space. But now you're sufficiently armed with line spacing skills, let's save this to our CircuitPython school folder, close that outermost tab, and let's talk word wrapping. So let's change our comment up top to wrap-text-demo.py. That'll be the name that we save this as when we're done. And now let's import the function that we're going to use. So I'm going to add a from, and that's inside the adafruit underscore display underscore text library. And I'm going to import wrap. And look, I've got two choices in here. One is wrap text to pixels, and the other is wrap text to lines. Now, wrap text to lines will wrap text based on a certain character count. I actually think that that's much less practical. That's because unless you're using a monospaced font, some of your characters are spaced differently than others. For example, a lowercase I takes up a lot less space than a capital W. I've never used wrap text to lines. I've always used wrap text to pixels. And in this function, we pass in a line width in pixels, pass in a string and a font, and the function's going to return a list of strings, none of them longer than the length of pixels that you passed in. So let's select wrap text to pixels. Then we'll change our print statement down below to say wrap text demo. And we're still going to create an object using the label class. But what we're going to do is pass in a string that's broken up so that it's no larger than a wrap text length. So we use wrap text to pixels. It gives us a list of strings. We'll combine that list of strings into a single string, and that's what we're going to pass into our label. So just above the label, the first thing that I'm going to do is create a constant to hold the width of each line. I'm going to call that wrap_width, and I'm going to set that equal to display.width /2 - 10. So this is going to give us a column that's half the width of the display with 10 extra pixels in there, just so that one column doesn't touch the other. Then I'll create a very long string to wrap. So I'm going to call this string_2_wrap, and I'll set this equal to the string. This is the leftmost column of magnificently wrapped text! Exclamation point. Next, we're going to use our wrap text to pixels function, and remember, this returns a list of strings. It doesn't return just a single string, so I'm going to name this variable that's returned list_of_strings. I'm going to set this equal to wrap text to pixels, and in between parentheses, I pass in the 3 parameters. The first thing is the string that I want to break up. That's our string to wrap, comma. Next, I pass in the width of each line, which is wrap width, comma, and then I pass in the font that I'm using, label font. That's important because depending on the font that you're using, you may have more or fewer words on a single line. And as a comment, I'll paste in the description, splits text into a list of lines so each fits within a given pixel width. Now what I want to do is take these strings that I've got back and combine them together into a single string, but I want to put a new line feed in between each individual element of the list. So I'm going to use Python's join function. It exists in all versions of Python, not just CircuitPython. That'll join all elements of the list of strings into a single string separated by line breaks. And this is how we do it. So I'm going to return a single string. I'm going to call this wrapped_string, set it equal to, and the way we use join is first we set a string, which includes whatever character or characters are going to be used to join the different elements in our list of strings. That's going to be the string \n, because I want to insert a line feed in between each string. Then after this, I just say .join, and in between parentheses, pass in my list of strings, which is list of strings. And again, this is just going to combine the list of strings into one string with \n between each element. So now down below, for now, I'm going to delete this second label. I don't need that. And I'm going to change my variable for my first label to read left_column. Make sure you paste that in between append. And I'm going to delete the string that I'm using as the text parameter for this label. And instead, I'm going to replace that with just the string wrapped_string. That should be my perfectly sized string with line feeds inserted so that no line is larger than my wrap width. And for me, the wrap width is half the width of the display, -10. That's it. I still want my anchor point and anchor position to be in the upper left, so we'll keep the 0, 0. And I'm going to highlight this whole left column through the group append, copy it, and paste it down below. And now let's create a right column. Copy and paste that name between the append. And above the right column, I'm going to set up a second string to use in this column. And it's okay to reuse the variables because the variables have already been used in the label above. There'd be no harm in creating new variables, but if we use the same variables, you can compare what we wrote below to what we wrote above. And the first thing I'm going to do is create a new string_2_wrap, and I'm going to set this equal to the long string, and this is the right column of utter wrapping awesomeness! Exclamation point. And just to show you, we created our wrapping string on 2 lines up here. We used CircuitPython's wrap text to pixels function to give us a list of strings, and then we used Python's join function to concatenate those different elements of a list of string into a single string with \ns in between them. Well, down below, I'm going to combine these 2 lines into just one line. That's actually the way that CircuitPython shows how to do this in their own tutorial. You can use either the 2-line method or the 1-line method. They do the same thing. Most of the time, I advise students that if they're faced with the trade-off to write code that's easier to read or code that's smaller, it's almost always better to write more readable code. That said, I don't think writing it on 1 line is too unreasonable, so let me show you what that looks like. We'll say wrapped string equals the string between double quotes \n, and this is where we say our join, .join, open and close parens. What do we pass into the join? Well, up here, I'm just going to copy my wrap to pixels function with all 3 variables. I'll paste that in between the parens of join, and that's it. We pass our long string to wrap into our wrap text to pixels. Wrap text to pixels is going to return a list of strings, each string in the list no longer than wrap width, and join is going to return a single string, joining together the elements of the list with \n in between each element. The right column below already accepts the wrapped string, so we're good. Let's just make sure we start this column in the anchored position that's halfway across the screen, so I'll change this first 0 to display.width \2. Let's also change the text color to yellow, 255, 150, 0. And let's open the terminal. TO's running. Be sure to click on your code and save. And hey, look at that. Magnificent. 2 columns. Everything's wrapping perfectly. None of these lines is longer than half the screen minus 10 pixels. Now, one thing worth noticing, the word magnificently and the word awesomeness don't fit on a single line. So CircuitPython has hyphenated those. It will hyphenate any word that's too big to fit on a single line. What can we do to fix this? Well, why don't we use a smaller font? Up here in our load font call, where we set up our label font, I'm going to change the font to Helv B14. That is a legitimate font that I have in my fonts folder. That is the correct spelling and the correct path for that font. So let's save and take a look at things now. And interesting, so awesomeness on the right fits on a single line, but magnificently wrapped is still hyphenated. And I think that's because magnificently wrapped has a hyphen inside it already, and that's considered to be one big word. So let's delete that hyphen, save again, and now our words wrap. We don't have any words that are hyphenated because they all fit within our columns. Cool! So there's some more display savvy skills, Pythonista. Be sure to save this file to your CircuitPython school folder as well, and close that outermost tab. Do me a solid, like, subscribe, drop a comment if you're enjoying things, but stay tuned because there's going to be more big learning on the way, and continue to hack.